Welcome back. This is an Aleks training video on calculating molality. We've already looked at molarity. Molarity is moles over liters of solution. I've got that here on the side for you in case you've forgotten. Molarity is moles of solute, stuff you're dissolving, over liters of total solution, including the solute. Okay, so the whole solution that the solvent makes. Molality is a little bit different. Molality is moles of solute, so there's still moles there. Molality over kilograms of solvent. Okay, so the solvent is before you put the solute in it. So before you put the salt in the water is a solvent. So molality, you're measuring the weight of the solvent. In molarity, you are finding out what the total volume of the whole solution is. Okay, it's just a little bit of a different tweak on that. So if you can memorize that, molarity, moles of solute over liters of solution, molality, moles of solute over kilograms of solvent, then you should be able to answer this question. A student dissolves 8.4 grams of sugar in 150 mils of a solvent, probably water, with a density of 1.16 grams per milliliter. The student notices that the volume of solvent doesn't change when the sucrose dissolves in it. Calculate the molarity and molality of the student's solution. Be sure your answer entries have the correct number of significant digits. So, what do we need? Both the cases we need moles of solute. Okay, so I'm going to have to take the sugar, which is the C12H22O11, and find out what's its molar mass, so that I know 8.4 grams of it equals how many moles. Okay, so let's start. I've got 12 times the atomic mass of carbon is 0.107. That'll give you 144.1284. Then I've got 22 hydrogens. So this was carbon, this is hydrogen, that's oxygen. 22 hydrogens. Periodic table says it's 1.00794. That gives me 22.17468. And oxygen, I need 11. And it says it's 15.9994. That gives me 175.9934. Add those together, and I get 342.29648 grams per mole. Okay, so that's how much it weighs for 1 mole of it. Okay, how many grams are in 1 mole of it? So I've got 8.4 grams, and it weighs 342.2968648 grams per mole. Okay, so when I divide that out, 8.4 divided by that, I get 0.0245413 moles. Okay, so in both of these cases, this is the number that goes on the top. So molarity is this number. So let's do molarity first. I'll just keep changing colors. Okay, so molarity is going to equal moles, which is 0.0245413, over liters. Okay, so it says 150 mils of solvent, but it notices that it didn't change. So we're going to still say that it's 150 mils of solution. Well, I need liters, so milliliters to liters, divide by 1,000, so I'm going to have 0.15, and molarity is going to be, so molarity equals 0.1636 dot 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 molar. Okay, I'll take care of that in a minute. So let's circle this because that's one of my questions. That was my molarity question. Let's go ahead and do it. What's the significant digits? I've got 8.4, that's 2, 150, that's 3, 1.16, that's 3, so I have to do it to 2. So 0.1636 goes to 0.16 molar. Okay, or 0. If you want to put the 0.16 molar, that will be the molarity. Molality, I've got moles already, that's fine, but I need kilograms of solvent. So how many kilograms? So it doesn't tell me how many kilograms, but it tells me its density. All right, so the density means, okay, 1.16 grams per milliliter equals so many grams over so many milliliters. Well, how many milliliters do I have? I have 150 milliliters. Okay, so it's already in milliliters, so I keep it there. Solve for grams. I have X number of grams over 150 mils. So multiply by the 150 to get X by itself. And when I have 150 times 1.16, I'm going to have 174 grams. Well, how many kilograms is that? I have to divide by 1,000. And so that's going to equal 0.174 kilograms of solvent. So I'm going to do it again. Let me change colors because I like changing colors. So I'm going to have molality equals the same number on top, 0.02454013 over kilograms of solvent, which is 0.174 kilograms. Okay, and I'm going to get molality, which is lowercase m. Uppercase m is molarity, lowercase m is molality. 0.141035. Okay, put a circle around that. And what do we have? We need two significant digits, so it's going to be 0.14. So it'll be 0.14 molality. And if you want to do molality as simply moles over kilograms, I think lowercase m also would be molality. Either case, it's the right answer. Okay, work hard.